Okay, so now I want to present this idea of things that can go wrong. So here's a thing that we ran into early on, where we had this thing that we called flock volcanoes. So these were, like, you look at the sedimentation tank and you'd see places where there were flocks just coming up, right up through the plate settlers and all the way to the top of the water in the tank. They would be intermittent, and it happened at the plant that was built for San Nicolas. And what was sad is the raw water turbidity was only 4 NPU, which is, you can see that in a glass, but it's not very dirty. And then the settled water turbidity, after it went through our flock filter and plate settlers, it varied between 0.5 and 4 NPU. So the 0.5 was decent, but the 4 NPU was like, goodness, we're not doing a thing. So this is the question, like, why is this happening? And in order to lead you along this story, here is some data from the plant. So they're measuring the settled water turbidity is the red lines, and the raw water turbidity is the blue lines. And the raw water turbidity has some little spikes in it. I don't know if it rained a little bit or what happened, but there was little spikes in turbidity. But really, these are all very low turbidities. It should be easy to treat this water. But look at the settled water turbidity, and I'll guide your eyes. Look at this. There's a peak, there's a peak, there's a peak in there. Okay, I missed one in the middle there, but the one in the middle, I'm not sure what that one's from, but it's likely from the peaks that were happening in the raw water turbidity. There's another peak, there's another peak. So what do you see? When are these peaks happening? It's about temperature. And what's the effect of temperature on water? Because it does two things to water. Let's go down. There's two water properties. It changes its viscosity. Which way does that go? If it gets warmer, what does viscosity do? Viscosity decreases, and when the viscosity decreases, that ought to help us, because in the flocculator, that means that the fluid deforms more easily, and so there should be more collisions. And in the sedimentation tank, the terminal velocity of the flocks will be higher because it's less viscous, and so we should be able to remove them easier. So viscosity was a dud as far as explaining this. What about density? What happens to density when the water warms up? It also decreases. I had to think about that for a little bit. So the water temperature increases, the density decreases, unless you're right at 4 degrees Celsius, and then there's funkiness, right? But we were warmer than that. We were in Honduras. So anybody see what might be happening? The story is, see, you didn't know all the information, but the story is that this community has a 14-kilometer transmission line. That's the pipeline that's bringing water from, it's actually a cave up high in the mountains where the water comes from. Oh, and this is a funny story. Every once in a while, the water coming out of this cave gets really turbid, which is why they need a water treatment plant. And it's a bit of a mystery why water coming out of a cave gets really turbid, because you'd think this is groundwater, right? So the local folklore is that there's a snake in the cave, and the snake gets very active at some seasons of the year, and that's why the water gets turbid. I don't actually know what's going on there, except, do you know about what karst means? The fact that there's a cave is consistent with the idea that this is a karst region. Karst means a limestone region. And in a limestone region, water can be dissolving the limestone, and so you end up having caves. And that means you can have water flowing underground in rivers, in channels. And so water that is subsurface in a karst region is not necessarily being filtered in the way that you normally think of groundwater being filtered. You can have completely dirty water flowing in underground rivers. And indeed, I've been at a river in Honduras where it's a nice sized river and it flows right up to a mountain and goes in. That was, and as we walk back to that region, we get to see caves as well and go into caves. So it all fits, right? There are caves, and the river can actually just dive into the mountain. And maybe it's that same river that's showing up on the other side of the mountain coming out from this cave with turbidity in it. Okay, so that was all along, that was a free story that had nothing to do with this problem, except that we've got dirty water. It comes 14 kilometers, and a lot of the terrain that they're bringing this pipeline on is pretty rough. And so they weren't able to bury the pipe. So they used galvanized iron pipe, and it's just laying on the surface. So it's exposed. And another piece is that the water board that runs this system was very conscientious, and they wanted to do a good job of maintaining their system. And so they kept that trajectory of that pipeline cleared. So they would send people up there with machetes and they would keep it cleaned. So that means that there's sun shining on their pipeline for 14 kilometers. And so you have a solar water heater. And so I don't have that data, but indeed the temperature was going up nicely every day, significantly. And that meant that the water at noon, the water coming into the plant is warmer than the water that is in the plant. So you have a tank of water, like in the sedimentation tank, you have a tank of water and it's kind of cool, and you have warm water coming in the bottom. Now, do you see what happens? You got warm, buoyant water, and it just races to the top. And it goes to the top so quickly that there's not a chance for the flocks that it's carrying to either get caught up in the flock filter or settle out in the place settlers. So that was an interesting insight. And the problem is, we don't know how to solve this one. It's a problem. It's a problem with water treatment plants everywhere. We did advise that they stop cutting back the weeds next to the pipeline so that the pipeline would at least have shade, but that doesn't completely solve the problem because it's the environment is still warmer, and so the pipeline still warms up. And yeah, an ongoing problem that doesn't have a great solution. And here's something that I'm working on currently related to sed tank design. I think that the water exiting our diffusers in the bottom of our tank may be breaking up flocks under some conditions. And so I'm thinking we need to slow those diffusers down. And so I'm working on a design that would allow us to do that. And the design challenge that I created for you for after you're done with the flocculator is going to be exploring a little bit of like the cost trade-off of what happens when you try to slow the water down in those diffusers.